Welcome back to the Mechanics of Solids lecture series. We're working on torsional stress and rotation examples. The next example we're going to look at is a problem from Mechanics of Materials by Timothy Philpott, Wiley 3rd edition. The assemblage is shown here on the right. The fixed plate right here in the middle is connected to a tube section, which is connected to an end plate and a solid rod up through the center with a torque applied at the end. So let's read the information in the problem statement and summarize. The solid steel rod, that's rod 1 extending through the middle, has an allowable shear stress of 18 kSI. So given rod 1 has tau 1 shear stress, allowable shear stress of 18 kSI. Okay. Second part of the statement, the brass tube 2 has an allowable shear stress of 6 kSI. I'll note that as tube 2, tau 2 allowable equals 6 kSI. The outside diameter of the tube is D2 equals 1.5 inches, and its wall thickness is T2 equal to 0.125 inches. And as already noted, the tube is fixed at point C and welded to a rigid end plate at B. Note that we aren't given a diameter for rod 1. In fact, that's something that we'll be asked to find in part B. Let's start with part A. We're to calculate the largest torque T that can be applied at the upper end of the steel rod if the allowable shear stress in tube 2 is not to be exceeded. I will summarize that as we are to find T so that tau 2, the actual stress, is less than or equal to tau 2 allowable. And as we like to do up front, consider what our working units are. Notice that stresses are given in KSI, lengths are given in inches. A torque has units of moment, or force times length. So I don't have a particular preference here. It's appropriate to work in kip inches, since those are the units that are given in the problem. I'm going to draw a little sketch to summarize the setup here. Remember that the system is fixed to a fixed plate at point C. Then we have tube section 2 extending down to the end plate at B, a rigid end plate. And then we have the solid rod 1 extending up through the middle with a torque applied at the end. And this is a solid rod. This is rod 1. This over here is tube 2. So as the torque is transferred, the applied torque will be transferred through rod 1 into the end plate and then transferred into rod 2. So this is equivalent to basically is equivalent to members connected, shafts connected end to end in series. So I could represent noting points A, B, and C on the diagram. I could also represent this as point C, then the tube section up to flange point B, and then the rod extending up to point A. I will get slightly different signs for my rotations if it's oriented this way, but otherwise, in terms of forces, everything else is equivalent. And an applied torque at the end will transfer all the way through the system and form a reaction torque at end C. And what that tells us is that the applied torque is equal to the internal torque in shaft 1, or rod 1, is equal to the internal torque in tube 2. And that is a result of the configuration being like shafts in series. So noting this very important piece of information, we will finish this example in the next video.